Hello guys, welcome back to the YouTube channel of The Concept Guy, and today we will discuss the Azeotropy questions again. And this is the second question that we have here today with us. And the question says that the Ergun equation used to describe flow of a fluid through a back bed is this. So this is the Ergun equation, and given that some values are given, so this value and this value is given to us. And what we need to do is we need to find out the voidage fraction epsilon of the bed. Okay, so we need to solve this equation for this epsilon value, epsilon that is E kind of this thing. And so we have 11 marks for this, and then we have another question. So first let's look into this question and solve this through Matlab. So here I have already opened Matlab, and this is the editor window. So here you see that I've written the function. So let's see what this says is, okay, so yeah, I hope it's visible. Yes, so this is delta p dp by L rho v square. So this whole thing is 100. I've taken this. So this is my function, as you see above. This is my function fvalve. Fval is something that I want the function to give me, and that is something the equation. So equation, when I say equation, this whole thing comes up to this left hand side, and on the right hand side we have 0. Okay, so as you can see, this is 100. So I've written 100 directly, 100 e to the power 3 by, so this function is void fraction, and it takes in an input e stands here for this void fraction, and that's the input to the function. So e to the power 3 by 1 minus e minus because this goes to the left hand side, minus 150, 1 minus e by 100. This value is 100, and minus 1.75. We have taken all these values to the left hand side. Okay, so that this is an equation, and we need to solve this equation using a inbuilt function in Matlab, fsolve. Okay, so I hope everything is clear up here. So this is my function. Okay, so what I will do to solve it, that this is in the editor window, I will solve it in the command window. Okay, so what I will do is I will put e. I want e, so my e is equal to, because I want e, so I will put e is equal to fsolve, the function, inbuilt function of Matlab. It's like function solve. Okay, it solves non-linear functions. Okay, so e is fsolve bracket at the rate, I need to solve for this e that is in the function. So if you see, my function has an input e. I need to solve for this input function, because I'm solving for e, and because I'm solving for e, I am getting e. Okay, so this could be e solution too. Okay, e solve means e solution. So my e solution that I will be getting after using this function is at the rate e, and my function is void fraction, and the input to this function is e. And next what we have, this is option. So I should start with an initial guess. So let's take, because void fraction is between 0 to 1, let's take a void fraction of 0.2 about, or we can take 0.5 also. So this is my answer. I have done the format long thing, so if I take format short and then again put the up, click the up arrow key, then I have this option, and this is my answer. Okay, 0.2742. To get a more accurate answer up to more decimal places, so for more accurate answer I will take format long, and that will give me this answer, this big answer. So I've solved the e, so my void fraction is 0.2742 or 0.274152 and so long. Okay, so 0.5 I have taken. Let's take another value. Let's take, if I have to assume that I will start from 30, it will give me the right answer again. Okay, but with more number of steps of calculation, because it has to actually minimize this fval. The fsolve function here minimizes this fval. I want fval to become 0. Okay, but what happens is that this fval is never 0 if I'm not that accurate with my e. Okay, so again and again the fsolve tries to reduce this fval to 0, at least near to 0. Okay, so let's take 38. I get this same answer. Let's take 39. Okay, I get a different answer, that is way too far than 1. So above 1 my voidage is not possible. So I have here also no solution found, as you can see, because last step was ineffective. So my solution was actually diverging rather than converging to this point, and this happened at when I put an input of 39, or if I say a greater input, let's take 390, then it comes to a convergence. So sometimes at some initial point the value doesn't converge, it in fact diverges. Okay, so fsolve is ineffective at those points. So sometimes you need to cross check. Like if I were to cross check, I would just put the void fraction. I will just call the void fraction function, and here I would just put like this value 1.5, which is of course not possible. Void fraction. Okay, so it is coming minus 676, but I need to get 0, right? If I were to run this with my e solve, okay, that is here, this thing, so it is giving a value closer to 0, hence this is the right answer. So you need to recheck again that your solution is correct or not. Next we look into the second question, and the second question is of 15 marks. and this says that the terminal velocity. So this is the terminal velocity formula. These are certain data that is given to us. What we need to find out is this terminal velocity, but we have some criteria given here. So my criteria is that for different value of Reynolds, I have different drag coefficient. Okay, so different ranges of Reynolds, I have different drag coefficients. So I need to find out a particular Reynolds and corresponding to this particular Reynolds, a particular drag coefficient, and then put this drag coefficient here to get a particular terminal velocity. That is my correct terminal velocity. We here will use this equation, these all equations we'll put them in if else statement. Okay, if this Reynolds is this, then this is my drag coefficient. If else if this is the range, then this is my drag coefficient. Else if this is the case. So I have already made a function on this that is Reynolds, and the function gives us f valve, and according to this f valve, the function takes in Reynolds value from us and then put if else statement. Okay, so it takes in if else statement, and then I have put in the various values here, and I actually did else if statement. If this is my Reynolds, then this is CD, and then finally I have tried to actually put my f valve is equal to the value of my V from this formula and my value of V from the other formula. So if I say this is one formula, and my other formula for V is that comes from my Reynolds number, that is rho. So this is P I've written here, the liquid density, rho V dP by U. U here is my mu. So it is kind of a same looking thing. So I've written U instead of this mu. That is the viscosity. So we'll solve this again with the same thing. So we'll edit this. Okay, let's write again. So my RE will be fsolve, and I need to solve for RE. So again RE here, small re, because we have taken here small re, and this Reynolds function. So Reynolds again small re, comma, we need to give a particular point to start with. So let's assume my Reynolds to be 100. Okay, so that is my Reynolds value. Okay, so the equation is solved. Okay, but we need to find if this equation is really solved to its correct value. So I need to put my RE, let's take 1000. Oh, RE 1000. So what is my correct value? Okay, let's say we put Reynolds 1000, and my f valve corresponding to this should be 0. So I need to have an f valve 0 when the V from this equation becomes equal to V from the other equation, f valve 1000. Oh, it's not 0. Let's put the other value that I've seen here, 3.3616. 3.3616. That would be okay. Wow, this is very near to 0. So what if we want a more accurate value? So what we will do is we will put options. Okay, what you can do is you can actually go to help with fsolve. Okay, so I am saying to Matlab that please help me with fsolve because I don't remember the thing or the code or to set the optimality tolerance conditions. So here I have this. Matlab gives me some data on fsolve. It has already pre-recorded in it, and okay, you can also read all of this stuff, but I will jump to the optimality thing. So here is optim options, and I will go to optim options, and here you see that optim options is something that options is equal to optim options. I have to write the solver name and then my optimality tolerance. So my optimality tolerance is 1e minus 3. So I could change it. So let's write it, options equal to optim options, and I need to use the optim option for my fsolve method, and in fsolve I have to change optimality tolerance, and optimality tolerance to 1e minus, let's say 8. Okay, now I have to run my fsolve. I will run my fsolve. So I will now run my fsolve again with the same 100 value, and this time I will put options here too. So options. Okay, so my options is actually the optimality tolerance limit that I've set, that 1e minus 8. Till this point my tolerance should be, so that I get a more accurate answer than this thing. It is e minus 0.6, so I need to get something kind of tolerance value of e minus 8. E here in Matlab stands like that 10 raised to power minus 8. Okay, so I get this answer, and let's put it in Reynolds. So Reynolds and my RE. Wow, this is very, very accurate. Like 10 raised to power minus 0.9 is really accurate. So you can actually change your optim options, but I guess till this point it is quite a satisfactory Reynolds number, and using this Reynolds number you can actually get the value of your V. V is, you can either use this function or this whole function. I would prefer to use this because this is very small, and you can get your terminal velocity. So I hope this question gives us 26 marks, that too very easily by using fsolve. You can also use functions like lsq nonlinear, but lsq nonlinear generally works for vector data. Better to use vector data for this. Like if I were to use lsq nonlinear, okay, lsq, that is least square non-linear. This is also a function. You can also take help lsq nonlinear and then put the, so it gives a very accurate answer to like this, but I will just prefer fsolve to be used because lsq nonlinear sometimes diverges way too far, and because it requires a more data set than this fsolve. So I hope you get my point, and please try to do it by yourself in Matlab and try various values of this input I've taken in 100. You can also try, because this Reynolds data is way too far, because so we can actually type